Okay, continuing on with 11.6, we are going to solve these quadratic equations by the factoring technique. Remember, the first step is we want to get the quadratic equal to 0. So on this one, I'm going to move the 64 over, or subtract 64. So I have 25x squared minus 64 equals 0. Now hopefully from 11.4, special factoring techniques, you kind of remember that this is going to factor into something called conjugate pairs. We have the 5x times 5x equals 25, and then we have 8 times 8 equals 64, but we have to get a negative 64, so I'm going to have a plus and a minus here. And those are called conjugate pairs. Okay, not really too important that we learn the vocabulary, but it helps with every course if you kind of know the vocabulary out, right? So we can do the set each piece equal to 0 or the shortcut method here. I'm going to set each piece equal to 0. Sometimes students will put a line between their two pieces, and then we'll solve each piece. So we subtract 8, and then we have 5x equals negative 8. Divide by 5. We have x equals negative 8/5. Or, and then when we solve this one, we probably know what's going to happen here, but let's just see the math again. This is some basic solving techniques here. We have 5x equals 8, and then divide by 5, and we get, or x equals 8/5. Okay. Next up, looking at f here, we see that it's not equal to 0, so I'm gonna move that 43 over, or subtract 43, or add 43, excuse me. So I have 16x squared plus 56x plus 43 equals 0. Okay, so now I have to mess around with the factoring of this, and you don't always get it on the first try, but I'm gonna try to factor this. For 43, I think 43 is prime. The only options are 1 and 43. So if I mess around with this a little bit, if I use 16 and 1, so 16x and x, and I put the 43 in the middle here and the 1 out here, I kind of get close. I get 16x and 43x make 59x, but it really doesn't work out, you know. And I think if you mess around with this one for long enough and you exhaust all possibilities here, you can't factor this, okay? And it's kind of a cruel one, because since it's not factorable, in this section we would say something like not factorable, and therefore we cannot solve with factoring. Okay, I'll double check that one, and if something's different, I'll let you know or make a video, but I don't think it's factorable. Okay, so you know, I could teach you a little technique here using Desmos, and maybe I'll just show that quickly, that if we open Desmos on the web, remember Desmos is that beautiful free graphing calculator. So if I open Desmos and I type in that quadratic into Desmos, now that quadratic was 16x squared. Remember, we got to get the squared from this little keypad here, plus 56x plus 43. Okay, so this is a little technique you could used to determine if it's not factorable by the factoring method. If you see here, when I click on these x-intercepts here, you see I have decimal numbers here. Because there are decimal numbers there, I know that that quadratic was not factorable. So that's a little technique that you could use, and then that might help you know and determine that this is, you cannot solve by the factoring method. Okay, and it's not, I guess, not just that they're decimals, but they're not clean decimals. Okay, they're irrational numbers, and they look like they're clean because they stop here, but they're not our familiar decimals like 0.3 repeating or 0.5 or 0.2. So that's just one technique you could use, and you can see if I zoom in on this even a little more, I think, well, I thought the decimal would go out further, but so that's one technique you could use to just see if something's factorable or not. Okay, so let's try to wrap up these last three here and see if we can get them done in this video. So this first one here, I spot that there's a GCF, so I'm going to factor out a 3x. Okay, there's a GCF of 3x, and factoring out the GCF of 3x, I have 3x times x squared plus 7x plus 12 equals 0. Now I'm going to factor my trinomial into x plus 4, x plus 3. Remember, you want to take time to make sure your factoring is correct. This one is going to yield x equals 0. You could set the piece equal to 0, but we've done that enough times that you might recognize that. This one, using the shortcut method, x equals -4. And this one, again using the shortcut method, x equals -3. So our solution set, if they asked us to write it out, and it doesn't have to be written in numerical order, but that could be our solution set. All right, looking at this h here, I'd like to keep my x squared term positive, so keep x squared positive. So I would probably move this 2x over to the right side, and I'd have 0 equals 5x squared minus 2x. Right? So if you don't like that, you can then reverse this to say 5x squared minus 2x equals 0. Okay? Because you know that if you have a equals b, you can reverse that and say b equals a. All right. So I'm going to factor out an x, and I have 5x minus 2 equals 0. Then I'm going to set this piece equal to 0. So there's one of my answers. And then using the shortcut technique on this one, I'm going to bring this off and change the sign. Remember, change the sign. And then I put it over the coefficient of the x term. And you can see my two answers now. If I write them in a solution set, 0, 2/5. Okay. All right, let's get through this last one here. It's a little bit longer, but I want to keep it on this video, and you can fast forward through the video if it's getting a little long for you. But on this one, it's definitely the longest one. We have to distribute this first, and we get 4x squared minus 2x. On this side, we get 9x plus 15. Okay, so we have to get all our terms onto one side and get this equal to 0. So I'm going to move this over, subtract 9x, and I'm going to move the 15 over, subtract 15. So I'm just kind of cramming that in there for a note to myself. So what I have is 4x squared minus 11x minus 15 equals 0. Okay? So now I need to start working on factoring this. Okay, and you know, you might not get it on the first try, like I've said before. So we could try 4x and x. Okay, if I put a 3 here, that's going to get me 12, which is close to 11. But the problem is I'm going to have to put a 5 here, and that's not going to be correct. Okay, I could reverse this and put the 5 here and the 3 here. That would get me 20, and that would get me 3. It's not going to make that middle term. Okay, so I'm going to abandon this, and I'm going to try 2x and 2x. Okay, and now I'm going to try 5 and 3. So let's see. If I put a 5 here and a 3 here, I get 15, which is good. If I try a minus here, that would give me minus 10. And if that's not going to work out. Okay, so it looks like this is not factorable. I'm going to check this in Desmos again, and we'll see whether this works out. Okay, so I have 4x squared minus 11x minus 15. Okay, so checking this out here, clicking here, I got minus 1 and 3.75. So those are nice clean numbers. Okay, so somehow I'm missing the factoring, and so I'm going to have to go back and check my factoring again. Okay, so let's go back and check the factoring. Okay, so I'm going to try the factoring again right here. So I have 4x squared minus 11x minus 15 equals 0. Okay, so I'm going to try 4x and x. I don't think I tried 1 here and 15 here. Let's try that. If I try a 1 here and a 15 here, okay, that's going to give me 4x on the outside, and that's going to give me 15x. This is going to work. Okay, so I missed the factoring, and the Desmos helped me spot it. Okay, so I'm going to put the minus sign here and the plus sign here. Okay, and if you check this out, it's going to work. All right, so using the shortcut method, change the sign on this. We have 15 and put it over 4, or change the sign on this, -1. Okay, now let's just take one last little look at Desmos and see, you know, here we got 15 over 4, which is 3.75, and this, which is -1. Okay, wow, you know, looking in Desmos, 3.75 and -1. Looks like that might be a good hint for us in the factoring. Okay. Well, this video got a little long, but hopefully you can fast forward through things. That wraps up the factoring, solving by factoring, and we have just a couple more problems from 11.6.